Hey guys, good morning. Welcome to, or good morning. You guys don't watch any of these in the morning. Good afternoon, good evening, good night. Welcome to Science 3.5B. Today is a lot less complicated or profundo or whatever you want to say than the beginning of the chapter, okay? Because remember, starting at page 73, the chapter started, or the section started introducing 6 simple machines. So Junior told me yesterday, sorry about that the WhatsApp version of the video did not have the little 2-minute video on the different types of levers. So I'm gonna put that out there as just a little YouTube link because it's only 2 minutes. It's not gonna take a lot of, no, I can put it out as a WhatsApp because I already have it on my WhatsApp. So I'll send that out on the group today with this one, but like detached, separate, so that in case you didn't watch it yesterday, you should watch it today so that you totally understand what levers are all about. But remember, there's 6 simple machines, so you only talked about levers yesterday in your notes. So today you're gonna talk about the other 5, and that is the rest of the section, you guys. Look at page number 75. Page 75 is about the wheel and axle, so you need to give me 4 sentences about the wheel and axle. Why 4? Even though the definition is pretty simple, because you need to talk about the IMA, okay? The equation for the IMA, remember the IMA is the ideal mechanical advantage, which means basically like how much of the work is the machine doing for you instead of you doing it. Like for example, a bicycle wheel is a wheel and axle machine. Well, a bicycle is obviously doing a lot of work for you because you don't have to walk somewhere, okay? So, but you're gonna see that it's more complex than that. If you look at page 75, figure 3.36, it's gonna show you the input radius, the output radius, that there's 2 different machines right there, even in that picture. So there's a lot of machines that make up a bicycle. It's the one in the back tire, it's the one in the front tire, it's the chain wrapped around the pedal. And so all of that is producing more force. Some of it is producing more speed. And that's the interesting thing about the wheel and axle machine, is that it's depending on what type of rotation it has as to whether or not it's producing more speed or if it's going to produce more force, okay? So both of those things are an advantage for a machine to give us. So you have 4 sentences on the wheel and axle. Then look on page number 76. You have 4 sentences on the pulley, okay? On the pulley, because there's different kinds of pulleys. And also I want you to specify about the block and tackle. What effect does it have on mechanical advantage? There's a different formula for mechanical advantage when it comes to the block and tackle pulley. So make sure you use the images at the bottom so you understand what they mean by block and tackle, single movable, single fixed pulley, different stuff like that, okay? So because those pictures help a lot. You can always look up a YouTube video if you want to understand even more. But I thought that these were very good explanations of these simple machines. And I don't want to make you watch a video every single time unless you search it out, okay? An extra video. So don't be thinking like, well, then why do you send so many? Okay, so look on page 77. You do need to do practice 3.5B. If you have any questions, just ask. I'm about to give you at the end of this video the answers from the practice 3.5A. Okay, so now you have 4 sentences on the wheel and axle, 4 sentences on the pulley, including the types that affect mechanical advantage. Then 4 sentences on the inclined plane. Okay? I hope that you can think when you're reading about these machines, you can say, oh yeah, that's why the supermarket uses that when they're unloading their truck. Oh, that's why I see that machine in this negocio and this negocio. Okay, because this is like an introduction to engineering, you guys. Physics is the foundation of engineering. Physics is the foundation of understanding that There are tons of inventions in the world already made to help you do your work faster and more efficient. And then there's more inventions that are needing to be made to help us do our work faster and more efficient and better, and where we can do more things because of these inventions. But these simple machines are the foundation of all those things. So you'll see inclined planes a lot in daily life. Pulleys, wheel and axle. Man, there's a 50 bazillion examples of how it's used in daily life. So 4 sentences on the inclined plane. Page 77, 4 sentences on the wedge. That goes over to page 78. And then on the last one, and by the way, on the wedge, you also need to specify how the mechanical advantage formula does change on that one as well. And on the screw, it also changes, okay? Hint for you that on page 79, there is a great little summary table right here to help you, okay? You don't copy that because there's no explanation, but it's there to help you organize your thoughts, to help you write about those things if you need that little hint. But it's not just to copy down like, oh yeah, wheel and axle, input radius over output radius, it multiplies force or speed and distance. No, that's not gonna work, okay? But you can add that information into your 4-sentence little paragraph to help you kind of focus in on the important stuff about those topics, okay? On top of doing those 4 sentences for wheel and axle, pulley, inclined plane, wedge, and screw today, remember you need to do practice 3.5B, you need to do practice 3.5C, and you need to do the section 3.5 concept review and application, okay? Here we go with the practice go over to page, let me get there. Page 73. Page 73. Let's go over the answers for practice 3.5A. A machine has a 3.5 meter input distance and a 0.5 meter output distance. What is its IMA? Okay, if you look over on page 72, it's just input distance over output distance, so your answer is 7. Number 2, like I told you, it was a machine with an AMA of 7. Is used to generate an output force of 280, so you just plug it into the formula and solve for input force. So it's 7, the equation's on page 73, AMA equals output force over input force, so you go 7 equals 280 over x, you solve for x, and the answer is going to be 40. Number 3, what is the AMA of a machine that requires an input force of 80 over a distance of 1 to produce an output force of 150 over a distance of 0.5. Well, they're basically trying to trick you, not trick you on this one, but they gave you more information than you needed. They gave you that information because of question 4. Remember, the equation for AMA is just output force over input force, guys. So that means that it's just 150 newtons over 80 newtons, so your answer is 1.875. But then you need the other information for number 4, which is calculate the efficiency of the machine. Efficiency is work output over work input, which means first you need to use your formula for work. Remember, your formula for work is force times distance equals force times distance, right? Which means you're gonna have to do 80 times 1 equals 150. No, pardon. I know me. Okay, it's force times distance. Is your work, okay? So you have your work output over your work input. Your work output is going to be 150 times 0.5, force times distance. Your work input is going to be 80 over 1. When you do this, you're going to get 0.937, whatever, so you get 0.94, and remember, efficiency is going to be in percentages, so it's going to be 94%. Okay? Seriously, if you have any questions, just let me know. We'll go over it a little bit more, which means that next week I will go over the Yeah, it's next week. I will go over the practice 3.5B and 3.5C with you. Okay? If you have any questions, let me know. Bye.